Question 14. A town's population P is modelled by the equation P equals AB to the power T, where A and B are constants and T is the number of years since the population was first recorded. The line L illustrates the linear relationship between T and log P for the population over a period of 100 years. The line L meets the vertical axis at 0.5 and the gradient of L is 1 over 200. Write down an equation for L. Well, we'll link this to the line y equals mx plus c. But in this case, instead of y, we have the variable log p, and instead of x, we have the variable t. So we can write log p is equal to m, the gradient, which we're told is 1 over 200, multiplied by t, the horizontal variable, plus the vertical intercept c, but the vertical intercept is 5. So that gives us the equation of the line L. Log p is 1/200th t plus 5. Find the value of A and the value of B. We begin this next part by writing the relationship P is equal to AB to the power T. Then we take logs of both sides. So the log of P is equal to the log of AB to the power T. Then we use our rules of logarithms to split the logarithm on the right hand side. The log of AB to the T is the log of A plus the log of B to the power T. And one final line of simplification. The log of B to the T is T log B. Now if we compare that with what we had on the previous page, we had log P was equal to 1/200th T plus 5. So we can see from that log A is equal to 5, which means A is equal to 10 to the power 5, since our logs are to the base 10. So A is equal to 100,000. Log B is 1 over 200, we can see. So log B is 1 over 200, which means B is 10 to the power 1/200th. And if we put that in our calculator, we get B is 1.0116 to 5 significant figures. Part C, with reference to the model, interpret the value of the constant A and the value of the constant B. Well, let's rewrite our relationship now that we know what A and B actually are. We can write population P is AB to the T. That means it's 100,000 multiplied by 1.0116 to the power T. Now if we put T as 0 times 0, 1.0116 to the power 0 is 1. So P is 100,000 when T is 0. So the A is the initial population, it's 100,000. What about B? Well, B is the 1.0116, and if we consider, say, after 2 years, we'd be multiplying by 1.0116 to the power 2, and after 3 years, we'd be multiplying by 1.0116 to the power 3. So every year, we multiply by 1.0116. So B is the number which the population is multiplied by each year. number by which population is multiplied each year. Part D. Find the population predicted by the model when t is 100, given your answer to the nearest 100,000. Well, we have the relationship p is equal to 100,000 multiplied by 1.0116 to the power t. So when t is equal to 100, p is equal to 100,000 multiplied by 1.0116 to the power 100. And when we put that in the calculator, we get 316,871. But we're asked to give it to the nearest 100,000, so that becomes 300,000 to the nearest 100,000. The second part of D, find the number of years it takes for the population to reach 200,000 according to the model. So this time we know P. P is 200,000. And that has to be 100,000 multiplied by 1.0116 to the power t. So if we divide by the 100,000, we'll get 200,000 divided by 100,000, which is just 2, and that's equal to 1.0116 to the power t. Now we'll take logs to the base 10 of both sides, and we'll get log 2 is equal to the log of 1.0116 to the power t. So log 2 is equal to t times log 1.0116, which means t is log 2 divided by log 1.0116, and that gives to the nearest whole number t is equal to 60 years. The final part of the question says, state 2 reasons why this may not be a realistic population model. Well, first of all, because it's exponential growth, it's growth without limit. Which is never realistic. And another thing we could say is it doesn't take into account factors such as disease, or famine, natural disasters which can affect the population. And that completes the question.